Good afternoon, everyone, and welcome to this session S22 on measuring the Internet protocol parameters for reducing Internet poverty. I am Anupam Agrawal. I am from India Internet Foundation. Together with me in this session is Anand Raje. He is also part of India Internet Foundation as well as chair of Internet Society Kolkata chapter. And we will be shortly joined by Bikram Shrestha, who is from Nepal Internet Foundation. So, Bikram, why don't you join us on the stage? So, while Bikram is coming online onto the stage, let me start. Anand, can you move to the next slide? So, the first question is, why are we discussing this topic now? This is based on what we are observing currently. What we are observing post-pandemic is essentially that there is a huge rush for digital and online. What essentially it means is, at a broad level, it is softwareization of everything. We had heard for like software-defined networking, but now you see that there is a software in washing machine, there is a software in heater. So everywhere you will find bits and pieces of software. So that's the broad trend which we are observing. We are seeing that there is a huge amount of automation coupled with artificial intelligence as well. And then there are large ecosystems of softwares which are getting created, which are interacting with each other. So a small app for an AC, which we generally use in our home to cool the rooms, that app is now interacting with the smart grid which is there by the electricity company. So huge amount of softwareization is leading to large software ecosystems collaborating with each other. And this exactly is the challenge now. The challenge is that from the organization standpoint, the challenge is that it needs to be continuously updated. It needs to be ensured that the units are running fine at the edge. There are issues related to cybersecurity and the safety of the instrument itself, followed by compliance-related requirements, whether there is certain amount of private data which is getting collected or not. And then finally, whether the things are working or not, the infrastructure related to internet and the bandwidth quality is appearing as one of the major and grand challenge, which needs to be resolved. So the situation is either there is no access, so while there are services digitally available, the people cannot access it at the end. And even if there is access somewhere possible, the quality of the bandwidth is such that the services cannot be taken online. So that's the tricky thing which we are landing. Next, if we move on, then we will see, Anand, next slide. Yeah. So what, how it is looking into the future. So there are set of challenges which are appearing from the environment standpoint, and then there are set of challenges which are the expectations of the people. So imagine a situation where most of the services are available digitally online, but it cannot be accessed because of the infrastructure bottleneck or the quality of the bandwidth bottleneck. And on top of that, if you add it up, then there is a requirement from the environment itself. The environment is becoming more and more dynamic. Things which were not thought of some time back is now getting possible. Say, for example, autonomous cars. Okay, the systems are evolving exponentially, and the rate of change of this acceleration is very, very fast. And then these are constrained by resources. So while there is a need for evolution, it is at the same time constrained by resources. And if you look from the expectation standpoint, it is expected that the services are intelligent enough to give, it is more intuitive in nature. The services are required in the sense that there is a great amount of good connectivity which is required, and most importantly, interoperability is the key function which is required here. I can give you an example. If you are working on an Amazon cloud and you want to port your data to Microsoft Azure, you will have to write the complete JSON file again. So with this kind of challenge where interoperability is a big issue, coupled with the access issue, coupled with the quality of the bandwidth, we are looking at a huge problem which needs to be resolved. So following on, there is a requirement for increased inclusivity and growing, and the scope of evolution has to be increased as well. Now, all this thing, when people are not able to access it, it is resulting in a thing called internet poverty, where people do have the means to pay for it, pay for the connection charges, but essentially they are not able to do it. They are ready to go on to the online world and expect things to be delivered digitally, but the quality of bandwidth is a restraint there. So Internet Society has done a project back, which is back. They have calculated an internet poverty index. So what we were thinking has now been translated into some kind of framework where 2 or 3 different parameters have been taken. For example, there has to be an affordable cost for gaining access to the internet. That is one dimension. The second dimension is whether the quality of the bandwidth is okay or not. And then whether the minimum data pack which is required for a person, which is considered to be 1 GB per month, at least that is what is available to the people or not. So this has resulted into internet poverty index. And while as a country we are the most connected nation in the world, in terms of internet poverty, this data has not been verified from the Indian context, but this is what has been projected in the ISOC website. We are landing up in a situation where we are number 2 in internet poverty. So we are connected, yes, but is the quality good enough? Possibly no. So that is what is resulting here. So all these things coming together, how can we solve this problem? It is okay to understand the problem. So we are doing whatever is required, but what is the possible solution? And that is what we are going to showcase as part of this session, that what can possibly be done. And if you move to the final, next slide, next. Yeah. So the solution is internet measurement and interoperability. So we understand there are challenges in terms of quality of the bandwidth. We understand that there are challenges in terms of the amount of bandwidth which is required for a normal person to do things which are required digitally. But if it is not there, then the way it can be managed is possibly through internet measurement. So we know that exactly where we need to intervene to make sure that the people are getting the right internet. And on this, we did a study on what are the parallel ecosystems on internet measurement globally. And you will be amazed that there are a lot of systems which are available globally. It is not only that we have done first, one of the systems which we have come to know over a period of time is from RIPE. But each one of these systems have taken their own fundamental stand as to how they want to operate. So if you take in terms of internet measurement for fixed line access, you will see that there are systems like BIS Mark, which is a parallel of MLabs. Then there is SAMNOS and DASU. So all these systems are there which are trying to understand that exactly where things needs to be intervened so that things, the quality of the internet can be made better. Next slide. So in terms of this taxonomy of this internet measurement system, if you take mobile access, then again, there are a couple of systems which are available. And on the operational support side, RIPE is definitely one of them. And Perf Sonar is another one which helps to understand that what is the kind of network utilization, what is the available bandwidth, what is the achievable bandwidth which is there. So bringing in all this together, saying that there are systems for internet measurements, there are systems which help us to understand that where are the problems. Still, one of the questions which remains unanswered in all these systems is interoperability. Are these systems interoperable? Possibly no. Can we take the data freely from these systems and try to use it for our economy or some other economy? Possibly no. So what we have done is we thought of creating an internet measurement system in India, which possibly is going to take care of this interoperability requirements as well. So this project is Advanced Internet Operations Research in India. And this is funded by Ministry of Electronics and Information Technology, Government of India, and it works through Software Technology Parks of India. We have Manjit Naik here, sitting from STPI, participating here. And this is again a large-scale internet performance project which tries to look at matrices at the edge. So I'll stop here and ask Anand to take us through this project, and he's the CTO for this project. So Anand, another 10-15 minutes yours, and then we'll go to Bikram to understand that what he thinks about this, and then we'll sum it up. Thank you.
Thank you, Anupam. And with these things in context, as India Internet Foundation being a community organization and also ISOC Kolkata chapter, how we can contribute for this and bring up a system which could be used by different stakeholders and also have answers to the questions raised by Anupam. So from a decade, we were working on these kind of issues, from installing root servers to understand the root server resiliency, also working on the DNS and the routing detours and what are the options and what are the solutions that we can come up. So internet measurement is one of the key factors and one of the key things that we thought would be can give a solution. But again, there were different platforms available. And as Anupam said, they were built on different perspectives in mind. Our perspective was something different. Interoperability was one of the bigger perspectives that we had. Then we had perspectives of understanding how DNS works and is there the Anycast and the CDN networks, if they are working, how they are working, and if we can collaborate with academia, industry, and other partners, how they could work on this. So this particular internet measurement project has different components of it, and internet measurement is one of the component, wherein we have a internet measurement network having 85 plus anchors across India, and we are going to deploy 500 anchors. These anchors are kind of, you can say, the probes which are capable of running any kind of protocol parameter testing. So they can measure any kind of protocol parameter. I can say protocol agnostic also, because it takes us around 2 weeks of time to integrate any kind of new measurement into these systems. Now the second part of this internet measurement platform is an Anycast network, which is we are having 5 Anycast networks across country, and these Anycast networks are having the DNS authoritative servers, root zone servers, and also recursive servers to understand how at a point of disaster or any kind of failure, how these networks could work, stand upon. It could stand upon DDoS attacks and other security threats. And academia and industry could start involving into these research projects. So these 5 Anycast servers are completely made on open source platforms and are made available to the partners who want to join into this research. So anyone who is interested into this, they can be provision a VM, they can, and it's completely microservices environment. So anybody could work on that. So that's one of the things, and this particular platform makes it interoperable. Then we are also working on root server resiliency. So these Anycast instances are also having 5 LRoot instances over there, which has been kept in the, which has been provisioned in all the Anycast instances. So there is a stack over there at the server level, and there's a stack over there at the edge level, and we are trying to understand the measurement matrices, and we are coming up with some of the solutions which could have answers to the problems of internet resiliency and other internet poverty index and other solution qualities which are actually hitting high. So if I go for the internet measurement network, these are kind of 85 plus measurement networks right now running across the country. The green ones you will say, and the orange ones, these are IPv4 and IPv6 networks. So any network, any anchor, it can be placed in any of the networks. It takes either a static IP or DHCP IP, and it connects to our central servers. And we can measure the parameters from those anchors. These are the 5 Anycast instances we are having. And these 5s are not only 5, it could be 7, 10, or 20 instances that we could have. These are some of the use cases that we can do with the measurement platform. We can have user experience measurement, routing detour forensics, measuring service national latency, DNS resilience from user endpoint, DNSSEC visualizer, DNS server health measurement in a geographic region, DNS forensics with anchor, network measurement tools, and academic research test bed. One of the things, whenever you just type in aiori.n in your mobile phones, and if you're connected, then it will show you where from you are actually getting served. This particular website is in Anycast instances having the same IPs placed in all the locations. So it can be your country's website or any other website, and it is showing you that the minimum latency from where you are actually being served. So right now, I think this presentation goes like, it was served from Bangalore and I was connected from Kolkata, but and it was 56.69 ms. And I think if Anupam, you could just take a look and where from it is getting served right now. So it is giving a clear-cut understanding that whether this particular service endpoints are located near to you, but you are served from a different location. So there is some issues in the regional peering. So the ISP should peer regionally, locally, and it could serve the purpose. So with these measurements, we could actually understand what are the problem statements underlying at the network layer, at the DNS layer, and other layers also. One of the key milestones of this project was to understand, is there any local routing detours that are happening across the locations. So these anchors can actually talk with each other. They are completely work on distributed computing paradigms. So each and every node is an edge node, edge compute node, which could actually talk with other node. So we can clearly understand that from one anchor to another anchor, if it is not taking the smallest route as per the routing hops concerned, then definitely we can see that there is a routing detour that is happening, and maybe it could lead to some other problem statements, and then we can work with the ISPs and other stakeholders to actually mitigate it or change it. One of the things in aiori.in website is you can just check any of the websites or any of the service points latency. So be it a government website, be it a website which is used by corporates or trading websites like Amazon and other websites, we can see the latency. So anybody who is a startup or who is any service wants to give service to any of the customers, they can easily see that what is the latency from a particular region. So here the greens ones are kind of having less than 30 latency. So they are kind of, these customers are happy with the service. 31 to 50, and again 51 to 70, and then more than 70. So actually the hosting providers, they can work upon that. Fine, my customers are from that particular point of view, from that particular point, but they are not getting our services properly. So that how to actually work upon that, you can work with this hosting provider. So it is kind of developed by the stakeholders and for the stakeholders. The same way, the DNS is a bigger part whenever there is we need to resolve names and numbers. So here, each and every anchor is running is a recursive server. So what happens over here is you can actually get insight of, from a particular point of view, that particular anchor, what is the DNS resiliency at the root level, authoritative level, and the recursive level. So these graphs are there, and it is not that we only can measure. anybody who is hosting this anchor is given a platform, and this platform is free of cost. So anybody who want to measure, it's a complete gamification. They can start measurement from their own. So this particular things that we are showing over here, anybody of you can just log in into AI.in and you can start measuring from yourself. So it is kind of made by the community for the community. So this is, again, the graphs are showing the registry.in latency from kind of Guwahati anchor. And this is the TLD zone. And this is one of the tools. So the idea was to work with the community and any kind of tool that could be incorporated in this particular platform. One of the tools is DNSSEC visualizer. There are visualizers across the globe and different visualizers are available. But we have seen the source code are actually not of use whenever we have tried to use those source codes in our visualizer. So we have started building tools over here. You just give your zone files, kind of 20, 200, 2000. This particular engine is there, which will give you understanding of whether there is a DNSSEC deployment over there or not, and what are the problem areas, and I can give you the report. So this is how, and this kind of tools, anybody, anyone can integrate any tool in this system. So it is a completely open-ended system. Any modules can be integrated. One of the things that we are now trying to measure, and from next conference and next workshop onwards, we will be giving results of what we are doing from this measurement unit. So this particular graph is showing we are trying to get the root server resiliency across a region. Like in RSEC caucus, it says that RSEC, one of the papers says that if there are 13 root servers and 8 root servers are available for a geographic region, we can say that it is having a root server resiliency. So this particular graph is showing that whether with that combined summarized data, at a point of time, what is the root zone resiliency, we can easily measure. And root zone resiliency is one of the aspects of user experience. There are different aspects of it. With this measurement infrastructure, we will club those aspects and we can go for health indexing of internet for a particular time. So these are some of the areas which could be, which is possible, and it is completely open source using CI/CD pipeline and some of the developers and researchers who are working on it. We are open for the collaborations, and we are here because we wanted to collaborate with other geographies also, so that it would be beneficial, and we can go for something, some more milestones. So over to you, Anupam.
So thank you, Anand. So the summary of what has been presented till now is that internet poverty to an extent is a technical problem, and there has to be a technical solution. So while there are public policy issues which needs to be tackled, there are things at hand which can be done to improve the user experience or the quality of the internet itself. Okay, so I'll rope in Bikram right now. So Bikram, what are your thoughts on this internet measurement and interoperability? And so if you can get your perspective, then we'll take it forward. Thank you.
Thank you, Anupam. Thank you, Anand. My name is Bikram Shrestha. I'm from Nepal. I'm representing from Nepal Indian Foundation. And Nepal Indian Foundation and India Indian Foundation is sister relation. So last time also we had one session in Sihanouk, and during that session I came to know that this platform is open and it's a reliable platform. So internet measurement is one of the key important things nowadays. We have been facing lots of reliability issues in our part of the, in our part in Nepal also. So if this system is, this software will provide, to measure the internet standardization standards, so it will be a very useful tool for everyone. In terms of, we have been using MRTG and PRTG in our corporate area, in our corporate platform. So in corporate area, we have been using monitoring the network, but this is something different. What Nepal India Internet Foundation has been developed with support from different stakeholders, and now Nepal Internet Foundation also want to collaborate with India Internet Foundation to make it implementation in our country. So we are very happy to have this platform to measure in our society, but somehow it's very flexible. I mean, it's very use case, and it need some technical background also. So I think India Internet Foundation and Internet Society will provide us in technical stuff to implement this. And one more important thing that if this can be have in collaboration with all other country, other environment, then it will be more useful to measure in our community. So I am very happy to have this platform in Nepal also. We are going to implement soon. Thank you.
Thank you, Bikram. So one thing, Anand, can you talk about the open source part of it? Is it available open source, not how it is?
Yeah, sure, Anupam. So it's completely open source right now. It's in our labs. So with the consultation with the stakeholders and the funding organizations, we are trying to get it completely community driven. And the best part of this particular project is, like, I am talking about AIORI.in. So if any other country or any other geography that wants to have it, it is capable of measuring any kind of website or any kind of service endpoints. And the engine and the visualization part, both are completely disjoint. It is API driven. So any kind of, it is not that the complete platform anybody need to replicate, but if say one geography or other entity wants to enjoy the engine therein, so we can expose APIs to them. So it is completely disjoint, API driven. Each and every layer is completely intact in itself. So integration can be done on any layer.
Okay, thank you. So any questions from the audience here?
One more question for Anand from technical side. So if there is DNSSEC is not implemented, so how in Nepal still I know that the DNSSEC is not implemented. So is there any tools to identify how this system will work on that platform?
The DNSSEC visualizer tool over here is completely crawling the complete zone data and try to understand the resource records, whether it is DNSSEC signed or not. And if it is not, it is flagging you that these are the issues that are there that you need to solve with. And also giving you some suggestions on what to do at each and every aspect. We are building the tool so that after you get the report from the tool, you will have one section wherein it will give you the problem statements, another section which will guide you through what are the steps that you should do in order to have a DNSSEC compliant zone files with you.
Okay, thank you. So we have 2 minutes. I don't see any questions online as well, so I'll just quickly summarize that there is a potential benefit in terms of improving the internet quality. Yep.
Thank you. My name is Shumais. I am from the Maldives, and I is coming from an island nation with isolated islands. I am curious to ask, in your project, did you also have this in Lakshadweep, and what in Lakshadweep? So
you are asking whether we have an edge point measuring from Lakshadweep? No.
Okay.
No, not yet.
Thank you.
Okay, so just to summarize this session once again, that there is a potential opportunity cost at this point in time if we don't do internet measurement from the edges. And that is going to be a big opportunity cost for all the stakeholders. That is one. Second, this is a part, yep.
Amrita Chaudhary for the records, Anupam. Thank you for this presentation which IIFON is doing. My question is, this is something which you are doing as a pilot at this point of time, which you want to scale. I'm sure there are funding issues which normally everyone faces. In your opinion, if, you know, not only would India but other countries be benefited from these kind of initiatives, which would help especially, you know, developing nations, etc. How are you looking at the funding challenges for scaling it up, not only for you but for others also who want to do something? Thank you.
Okay, thank you. So the core cost of any such system is in the first phase itself when you are developing the project. Okay, so this project, the major cost has been taken care of in terms of development. Now what you're talking about is implementation or the rollout into various geographies or various countries. That is going to be only an incremental cost to it in terms of buying the minimum hardware and in terms of requiring people to get it deployed at various places. So that cost is going to be nearly 1/10 of the development cost. Okay. To give you an estimate that how are we managing the funding challenges, this is exactly how we manage our homes. Okay. When you are requested a lot of things to buy but you can't. So it is a resource constrained environment, definitely yes. And there are stakeholders whom we are approaching literally every day and night to ensure that we get the funds on time. Apart from that, at this point in time, we are also approaching organizations like APrIGF, ISOC, who do have an existing measurement platform to some extent to see that whether we can make it interoperable. And that answers the point raised by Bikram that whether it can work with other measurement ecosystems as well. So for any measurement system to get 20,000 probes deployed globally is a big challenge. Yeah. Just summarizing, yeah, is a big challenge. So while RIPE could have 10,000, AIORI can have 2,000, and all these platforms start exchanging data, then I think we are solving the problem globally. Thank you. Thank you, Anand. Thank you, Bikram, for being here, and thank you, audience.
Thank you
for
for listening.